Hey everyone, this is Umakant. Welcome all of you to my channel. So here I am with a new video. So in this video I will discuss the most expected questions for BRC 2022. So for the physics discipline. So I would like to suggest one thing like that from my experience. You will get nearly 15 to 20 questions like I will discuss today. So basically in this session I am taking very standard questions, not any kind of thorough or tough questions. So let's have a discussion on the questions. Okay. So this is a question from solid state physics. The energy of a charge carrier in valency band of a simple cubic metal has the form E equal to AK square plus B. So first of all, the dispersion relation is given. This is very important question. Okay. So AK square plus B. Here A is the constant given. The magnitude of the wave vector and the V is constant. So find the value of effective mass by M. So you have to find the ratio of effective mass by M. So basically, if I solve all the questions, then it will be very long. So I will show the approaches. So please you try all the questions. Okay. So fine. First of all, you know the effective mass is equal to h cot square by d square E by dk square. So generally it will be h cot square by 2a. Okay. So now effective mass by M is equal to h cot square by 2a, okay, into M. So this is the value, and you know h, a is given, and you put the mass of electron. Okay, so you can calculate this value. So exactly this question will be given, like because here you have to put all the value and you have to calculate this quantity, so it will take time. Okay. So the next question is from quantum harmonic oscillator. The Hamiltonian of particle is given by h equal to h cot omega a dagger a plus a dagger a over a. So condition is given, a dagger commutation is 1. So find the eigenvalue. So just operate over n and use two property, that is a over n. Okay, a over n is equal to root over of n minus 1, and a dagger over n is equal to n plus 1 root over n plus 1. So once again here operate n, so you can calculate this quantity and this will be energy eigenvalue. So this kind of question can be expected. Okay. So next is from solid state physics. The question is from lattice vibration of diatomic molecule. So consider the phonon spectra of two-dimensional lattice. So dimension is 2, so d equal to 2. 3 atom per unit cell. So number of atom per unit cell is equal to 3. Find the number of acoustical and optical mode. So as you know, number of optical mode for 2 dimension is 2p minus 2. So it will be 2 into 3 minus 2. So it will be 6 minus 2 equal to 4. Number of acoustical mode equal to 2. So this will be number of acoustical mode equal to 2. Okay. So 4 and 2 will be the correct answer. So option C will be correct to the answer. Okay. So next is from digital electronics. So it is very easy. So you can calculate, like this is will be not gate. So it is a bar. So this will be a b bar whole bar. So then it will be a bar, a b bar whole bar. Then it will be b bar, and this output will be bc whole bar. So it will be b bar, bc whole bar. Then it will be a NOR gate. So it will be a bar, a b bar plus b bar, bc bar whole bar over whole bar. So use the De Morgan theorem, that is a plus b whole bar equal to a bar into b bar, a b bar whole bar equal to a bar plus b bar. So you can simplify this question. Okay, so this kind of question can be expected, and such question was asked in 2020 in BRC examination. This is not the question exactly taken. This kind of question was asked in BRC. This is a very nice question from solid state physics. So consider a three level system which has ground state minus delta and two excited state with the same energy delta. So ground state is minus delta and two excited state having energy delta. Okay. Then it is connected to a heat reservoir temperature T. So if connected to heat reservoir T, then it is a canonical system. So it is a canonical system. Okay, so now find the probability of finding the particle in the ground state, that is minus del state, when t is equal to delta by minus kp, delta by kpt. So this is a very standard question. So first of all, write the partition function. So partition function will be e to the power summation e to the power minus beta ei, so gi, so degeneracy will be 2 for the state. So it will be e to the power beta e plus 2 into e to the power minus of beta e, matlab delta, it will be delta. Okay, so this will be the partition function of your system. So now you have to find the probability of finding particle in the ground state, that is minus delta energy state. Okay, so it will be, probability will be e to the power minus beta into minus delta by partition function, that is e to the power beta delta plus 2 into e to the power minus beta delta. So now put beta, you know beta is equal to 1 by kbt. So put t is equal to delta by kp, so you can find this probability. So calculate it. Okay, so this is the approach. This is a nice question. Then this is a mostly expected question from BARC point of view, like canonical transformation in classical mechanics. So you know, as for the canonical transformation, p or q commutation should be 1. Okay, so it will be like del p by del small p, del q del small q minus del p small q del q del small p equal to 1. So apply this condition and you check what is the value of alpha and beta, so that this value will get 1. Okay, so this is the approach, and this question is repeated in 2020 bar, 2021 bar question was there. Okay, so you may expect this question in this year also. So the concept is same, but it can be framed in different form, like in GATE 2020 there is a question. So this is a fine question from classical mechanics. The Lagrangian described for a particle of mass 2m. So mass of particle is 2m, moving under the conservative force F is equal to minus 2x minus 5 by x. So basically it's very easy. So potential energy will be minus del F by del x. So it will be 2 minus 5 s square. So this will be the potential. Okay, take the derivative of f. So minus 2x will be 2 plus 2, because minus is there, then minus is there, so it will be plus, again 1 by x equal minus 1 by s square. So then you have to write the Lagrangian, that is kinetic energy minus potential energy. So it will be half m is 2, that is 2m, x dot square, it will be velocity term, minus b, that is 2 plus 5 by x square. So solve this term, you will get the answer. So this is the answer, you have to rearrange it. Okay, so as seen in this as seen here. Okay, move to the next question. This is a very basic question from solid state physics. So the question is asking a rod of copper and another is germanium. So one is copper, so it is metal, and germanium is semiconductor, is a indirect semiconductor. The identical dimension, both have identical dimension, and cooled from room temperature to 80 Kelvin. So they are cooled. Okay, so both the systems are cooled. Then the resistance will temperature which vary. So you know, for metal, if we increase the temperature, your resistance get increased, but in case of semiconductor, if your temperature is increases, your resistance get decreases. So one thing I should mention here, those people are preparing for the PhD interview, this question is mandatory. Everyone will ask this question, how to determine which is metal, which is resistance. So you have to answer like, you have to check resistance versus temperature curve. So how and why for semiconductor with temperature resistance decreases? Because as you increase the temperature, number of electron from the valency band to the conduction band moves increases. So as the number of carrier increases on the conduction band, so conductivity increases, so the resistivity decreases. This is the explanation. So here for copper, resistance will decreases because you are cooled the system. So for copper, resistance will decreases, and for germanium, okay, it is increases because you are cooling the system, so that copper resistance will decreases, and germanium resistance will copper resistance will decreases and germanium resistance will increases, because as you cool the system, number of electron will stay on the valency band. Okay, so you need the electron on the conduction band for the conductivity of the material. Okay, so then it is a question from mathematical physics, and this question is all about the Clay-Hamiltonian principle. And as I already mentioned, this Clay-Hamiltonian principle is very important. So as for this Clay-Hamiltonian principle, a matrix should obey its own characteristic equation, that is A minus lambda E not equal to 0. So if you apply this here, so it will be 2 minus lambda 3 5 0, 2 minus lambda 13 0 0, 2 minus lambda mod equal to 0. So it will be 2 minus lambda whole cube. Okay, 2 minus lambda whole cube equal to 0. Okay, that is 2I minus lambda whole cube equal to 0 0. So option A will be correct for this question. Okay, 2 means here's 2I, identical matrix is there. So here is a mathematical question from Laplace transformation. So what will be the Laplace transformation of this function? So generally you know Laplace transformation of f of t is equal to f of s is equal to integration from 0 to infinite e to the power minus st f of t dt. So if you apply this, then it will be ranging from 0 to 5 first, and for the t greater than pi it is 0, so don't worry for this region. So you have to check for this region. So I take the integral from 0 to pi. So here f of t will be sin t e to the power minus st dt. So solve this integral. Okay, so thank you so much for watching my video. Hope your preparation is going well. All the best for the examination. So on the incoming days I will upload more the expected questions so that you will get benefited. Thank you so much for watching my video. Thank you for your support.